Hello, thank you for joining me today. Before we get started for today's lesson, it would be helpful if you had a pencil, some scratch paper, an eraser, and a partner to help you during partner talk today. And don't forget, you can always pause the video and go back to parts of the video that you want to review. So I'd like to start with a question. Why do you think it's important that we're using models to show how fractions are multiplied? You can pause the video and write down some ideas or chat with a partner if someone is with you right now, and then start the video when you're ready. I think it's important to use models because models help us understand the value of a fraction, and it also helps us see how fractions can be multiplied and how that number changes. It gives us a visual representation that makes it easier to understand when we're solving problems. So with that, we're going to continue to use models today, and we're learning how to use models to multiply a whole number by a fraction. I want you to think about your level of understanding before we get started. How do you feel about today's learning objective? If you watched the video before, we used bar diagrams to help us with multiplying fractions. Now we're going to be using models. We'll continue with that, but we're going to be multiplying a whole number by a fraction a little bit differently. So based on what you already know, I want you to write down how you're feeling right now. I'd like to review some multiplication practice that we've done in the past, and I know you learned this in 3rd grade as well. When we're multiplying, like 3 times 4 equals 12, we can use something called repeated addition to help us solve the problem. We're going to be using that repeated addition today with our fractions. You'll see what I'm talking about when we get to our modeling and practice. But this example I just wanted to remind you of. And I'd also like to bring up what we talked about the other day using bar diagrams. We can find parts of a number using bar diagrams like this, and the model helps us understand what we're breaking apart. For our big idea today, we're going to multiply a whole number by a fraction using repeated addition. If I want to find 1/3 times 3, I could use repeated addition. I can make models and repeatedly add them to find the answer. And we'll come to more of this in just a couple of minutes. Our success criteria for today is information that we've already learned that can help us be successful. We can use bar diagrams to model fractions. We can represent fractions with models. We can interpret fractions as division, and we can use bar diagrams to find parts of a number. So let me show you this first example. Find 1/3 times 3. My whole number is 3. I'm going to circle that. I'm going to multiply 1/3 3 times. So I'm going to make my model for 1/3 3 times, and I'm going to use repeated addition to add them together. And my answer would be a model that is completely filled in because I have 1/3 here, 1/3 here, 1/3 here, and it all fill in this one model. So my answer would be 1. Just going to erase that there. So our steps are to identify the whole number, draw models to represent the fraction, add the models, and draw a new model based on our addition, write the fraction, and simplify if we need to. I'm going to show you one more example, 2 times 3/4. So the whole number is 2. I know I'm going to be adding the fraction 2 times. I'm going to draw the model to represent the fraction based on the whole number. So I have 3/4 and 3/4. I drew it 2 times because of my whole number. I'm going to add the models together, draw a new model. So I have 1, 2, 3, 4, 5, 6. So I draw my new models, 1, 2, 3, 4, 5, 6, and that gives me 1 whole and 2/4, but I need to simplify to 1 and 1/2. So let's practice these. If you want to pause and try them on your own, you can, or if you want to follow along with me, you can do that too. So I have 4 as my whole number, and I have 1/2. So I'm going to draw my models, 1/2, and draw 4 of them. I'm going to add them together. When I add them together, it's going to equal 1 whole, because these two together would be 1 whole, and then another whole because these two together would be 1 whole. So my answer with 1 and 1 would be 2. And let's use our partner talk to explain our thinking. I found the answer by, I can solve this by, I understand this because, I need more help with, I can check my work by, I can make a parallel connection to, it is important to know this skill because. Let's try another one. 4 times 1/3. Again, if you want to pause and try it and then come back and see the answer, you can do that too. So I know I'm going to be drawing the model 4 times. I have my 1/3 model. There's 1/3. And there's 1/3. And here's 1/3. And here's 1/3. Now I know if I put these 3 together, that's going to give me 1 whole because they're all going to be filled in for that. And then I have this one left over, which would be 1/3. So my answer is 1 and 1/3. Let's use our partner talk to describe what we did. Let me erase that so we can see it a little bit better. And I would say I can solve this by using models and repeated addition. Okay, let's try this one. 3 times 2/3. So I have my thirds here, 2/3, and 2/3, and 2/3. My whole number is that 3, 2/3. So when I add them together, let's see here, I'll have those two, and then I'll bring this one over. So that's these two fill in here. This one comes here, this one goes here. This one goes here. And this one goes here. That means I have a total of 2. So my answer is 2. I'm just going to go over this one more time. I'm going to use a different color. So this is 2/3, 2/3, and 2/3. I brought this one here, 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 and this one here. And this drawing isn't the best, but just wanted to show you the representation and why it equals. I have 1 whole here and 1 whole here. And again, going to my math talk, I can say I can check my work by drawing models to check my answer. Let's try a word problem. Over the past 6 hours, Natasha spent 1/5 of each hour making cookie dough. How much time did she spend making cookie dough in all? Well, over 6 hours, she was spending 1/5 of each hour. So I could draw my models to represent 1/5. 1, 2, 3, 4, 5. And I know that I'm going to add that 6 times. I want to show you that even if I draw them out, I can draw out 6 of them. I know that 1 hole is going to be filled because there's 5. If I have 6 boxes, I'm just going to draw them out quickly here. I know that I have 1, 2, 3, 4, and 5. So 1 hole is going to be filled, which will just leave me with 1/5. So my answer would be 1 whole and 1/5. So using our math talk, how can we explain what we did? I found the answer by, I understand this because, I can check my work by, And I think the models really help us understand what we need to do. So what was our learning objective today? We are learning how to use models to multiply a whole number by a fraction. I want you to think about your level of understanding before we started and write down the number of how you feel now. Has it changed? Have you increased? Or do you need more help? You can always go back to the video to review the problems again. I wanted to ask you also, how do you think 2/3 times 12 is related to 2 times 12 divided by 3? First, I want to solve 2 times 12 divided by 3. 2 times 12 is 24, divided by 3 is 8. If I were to solve 2/3 times 12 using models, I would have to draw out 12 models of 2/3. I want you to go ahead and pause the video and try to solve that and see how they're related. Well, I wanted to show you a little relationship here. If I were to do 1/3 times 12, it would be the same as saying 12 divided by 3. Since 2/3 is 2 times as much, I could just multiply 2 times 12 divided by 3. And this was just a quick statement here, just to show the relation, to see if it was something that you could solve too. Finally, I want you to look at this model and write and solve a real-world word problem that could be represented by this model. You can pause and try to write your own problem, or you can listen to the one I've come up with. I would say something like, it's been 5 days, and every day Ben walks about 1/5 mile. How many miles did he walk in all? Well, if he's walking 1/5 for 5 days, at the end he would have walked a total of 1 mile. I'd just like to say thank you so much for following along with this video. We were learning how to use models to multiply a whole number by a fraction. Don't forget to like this video and subscribe to listen to more direct instruction videos. Thank you so much.